All right, welcome. If you've got your PCI Level 1 and 2 exams coming up, then you have landed in exactly the right spot. We're going to break down the core concepts of concrete durability. The stuff you absolutely have to know to walk into that test feeling confident. So, let's dive right in.
So keep that question rattling around in your head. It's fundamental to pretty much everything you're going to do as a quality control professional. We will get to the answer, and trust me, it is a huge deal. But before we get there, let's take a quick look at our game plan for this explainer.
Okay, here's our study guide. We're going to hit every one of these critical areas, and we're going to focus on exactly what you need to know to not only pass your certification, but to be great at your job. All right, first things first. As a QC pro, you gotta know your enemy, right? A durable product starts with knowing what you're up against. So let's jump in and look at the common factors that are always trying to take down good concrete.
Look, you're not expected to be the design engineer who prevents all this stuff. That's not what Level 1 and 2 is about. But, and this is a big but, you absolutely have to be aware of these issues. You are the eyes and ears on the ground, and you need to know what a potential problem looks like.
And this really gets to the heart of it. The crucial word here is consistency. This is where you are so important. As QC, you have to ensure that the approved project materials are the only materials used every single time. Because one little unauthorized swap can throw the whole design right out the window.
Okay, now for a big one. Let's talk about concrete's secret weapon. Its hidden shield, air entrainment. You're gonna want to lean in for this part. I can pretty much guarantee you will see this on your exam, and it's a concept you'll deal with every single day.
And to be clear, we're not just talking about any old air that gets trapped during mixing. No, this is a deliberate, engineered process. We're intentionally creating a network of billions of tiny, stable bubbles to give concrete a superpower, the ability to survive freezing and thawing. You need to lock these two functions in your brain. This is the whole why behind air entrainment. The bubbles block pathways for water and chemicals to get in, and, this part is brilliant, they act as tiny pressure relief valves for when water does get in and freezes. It gives the expanding ice a place to go without cracking the concrete. Simple, but incredibly effective. So where do you fit in? Well, your job isn't to fix the mix on the fly. Nope. Your job is to be the reliable source of truth. You test the air content accurately, and if it's outside the specified limits, you report it. Immediately, you provide the correct data so the engineers can make the right call. All right, let's switch gears a little. Now we're going to look at the mix ingredients themselves and how they affect the final product. Things like how much it weighs, how it looks, and making sure all the parts play nice together. So you should definitely be familiar with these general categories. But for you as a QC tech, your primary job here is actually pretty straightforward. It's a visual inspection. Did the right aggregate, lightweight or normal weight, go into the batcher? It's a simple check, but getting it wrong has huge implications for the project. Okay, here's another good little exam tip for you. Again, you don't need to be a mix designer, but you do need to understand the risks involved. If you see a product using two different mixes, like a face mix and a backup mix, you need to know that if they're not compatible, they can cause serious problems like bowing or delamination down the road. It's all about being aware. How concrete behaves when it's fresh is just as important as how strong it is when it's hard. This is all about workability. And this topic leads us to maybe the single most important rule you will ever have to enforce. And your number one tool for checking workability on the plant floor is the slump test. It's a quick, reliable snapshot of the concrete's consistency, which brings us to the golden rule, the one you can never, ever let anyone break. I cannot stress this enough. You can never, ever let someone just add water from a hose to a mix that seems a little stiff. It is the fastest way to destroy strength and durability. You are the gatekeeper. You are the last line of defense against this. It is absolutely not negotiable. And this slide really lays it all out, doesn't it? If a mix needs to be more workable, the solution is not water. It's the controlled, authorized addition of a high-range water-reducing admixture.
This is how you get the flow you need without sacrificing the quality you are there to protect.
Hey, remember that question from the very beginning? What's the single most critical ratio in precast concrete? Well, here's your answer. This concept is the absolute heart of concrete quality control. You have to understand this inside and out. And pay close attention to the letters WCM. That M stands for materials, and it is so important. You're not just comparing water to cement. You're comparing the weight of water to the weight of all the cement-like materials. That means cement plus fly ash, silica fume, the whole shebang. If you only remember one number from this entire explainer, make it this one, 0.45. This is the maximum allowable water to cementitious materials ratio for precast concrete products. Burn it into your memory. It will be on the test.
Now, here's a little nuance you've got to understand. Production allows for a tiny bit of wiggle room, right? A tolerance of plus or minus 0.02. So a mix designed at 0.42 might come out at 0.44, and that's okay. But that 0.45 number, that is a hard ceiling. It is a brick wall you can never, ever go past.
Finally, let's talk about admixtures. These are powerful tools, little chemical modifiers that can do amazing things for concrete. But they come with their own set of rules. And guess what? You're the one who has to enforce them. Your role isn't to be a chemist, it's to be a verifier. You're running through a checklist. Is this the right admixture for the job? Is it compatible with the other ones being used? And critically, does it meet the chemical limits, especially for things like chlorides, which can cause the rebar to rust from the inside out? And this is what it all boils down to. These are your core responsibilities. This is the list you need to master for your certification. This is the foundation of being a great quality control professional in this industry. The answer to this question shows whether you really get it. It's not just about knowing the rules. It's about applying them correctly when things get real. Your knowledge, your certification, that's what protects the integrity, the safety, and the long-term durability of every single product you oversee.